This is a little recording where we're going to show how to use a table of values to classify a polynomial. And if you're with K-12, WAVA, you'll find this problem on page 201. It's number 28. The directions say, determine what degree the power function has using the table of values. So here are the table of values. Basically, we're given values for x, and we're given values for the function h of x. 45, 0, -5, -40. And, remember, another way of thinking of h of x is y, a simplified way of thinking of that. So basically, it says, we've got to do this thing called successive differences. We've got to take a look at h of x and take the successive difference between each of these values. So I'll show you. We'll start with this first one here. We'll go 40 and 5. So the way it's going to look, it's just going to be 40 minus 5. You just put a subtraction sign there. So we'll say 40 minus 5. That's 35, right? Okay. Then we're going to do the same thing here. We're going to do 5 minus 0, right? 5 minus 0. What was 5 minus 0 equal to? 5 minus 0 is just equal to 5. Then we'll just keep on going like this, and we'll go 0 minus, now remember this is a minus 5. Whoa, it gets a little weird, a little bit hairy here, but it's a negative, we're subtracting a negative, so that's going to be the same as a positive, so it's going to be 0 plus 5, and that'll just be 5. And then we're going to have negative 5 minus a negative 40. Again, it's getting kind of weird, but it's just fine. It's the same as negative 5 plus 40. So if you have a positive 40 and a negative 5, that's going to be 35. So now we take a look at this first level here, this first tier. And are they all the same? No, they're not the same. That's what we're trying to do. We're trying to do successive differences to find a place where they're the same. So this is the first iteration, and they're not the same. So we'll repeat the process. And we get 35 minus 5, and that's equal to 30. We'll get 5 minus 5, and that's equal to 0. And we get 5 minus 35, and that's negative 30. Are these the same? No, they're all different. So the second iteration is doesn't meet our needs, right? We need them all to be the same. And so we'll do it one more time. 30 minus 0 is 30. 0 minus a minus 30 is the same as 0 plus 30, and that's 30. There they are. The third one is the same, right? So then that means, since the third difference, since they're all the same, that means this is a cubic function. And remember, cubic is cubed. It's 3. And that's how you do it. If you get to the third one, it's a cubic. If you get to the second one, it would be a quadratic or squared, right? If this is the first one, it's linear. Now, let's take a look at how we can actually come up with the form of this function. So watch. We know the general form of a cubic is going to be basically h of x is equal to some value. It's going to be a cube, right? It's going to be a cube, and we don't know what the a is. It's going to be some coefficient times that. But what we do know, look at this. We know that when x is negative 2, h of x is equal to 40, right? So we can go back into this general form and say, well, what happens when x is negative 2? Well, we could take and put. Well, we say, well, a negative 2 cubed, and what's h of x? H of x is just 40. There we go. So now we could say, okay, what's 2 cubed? Well, 2 cubed is just, or negative 2 cubed is negative 2 times negative 2 times negative 2, right? And negative 2 times negative 2 is 4. Negative 2 times, or 4 times negative 2 is negative 8. So we know negative 2 cubed is equal to negative 8. and we can rewrite that as negative 8a. So we know that 40 is equal to negative 8a. Divide both sides by negative 8. Divide by negative 8. We get negative 5 equals a. Voila, look at that. So we know h of x is equal to negative 5x cubed. That because a is equal to negative 5, so we can pop that in there. Okay. I hope you found this to be helpful.